Welcome to all. Today we are going to see about Bragg rating. Any periodic variation in the propagation medium is called the Bragg rating. So, what is perturbation? It is a periodic variation of the refractive index of the medium. Here, we assume it is a change in the refractive index. That is, a variation of refractive index of the medium is taken in the Bragg rating. What is the use of this Bragg rating? It is used as filters, error of multiplexers and compensators. How Bragg rating can be formed? It can be formed by the propagation acoustic wave in the medium. So what is an acoustic wave? A pressure wave. The change in the application of pressure will lead to formation of waves. Those waves are called as acoustic waves. Now we are going to see the principle of operation of the Bragg rating. Consider two waves propagating in the opposite direction with the propagation constant beta naught and beta 1. So the forward propagation wave is having a propagation constant beta naught and backward propagating wave is having a propagation constant beta 1. The energy is coupled from one wave to other if they satisfy the Bragg phase matching condition. So what is the phase matching condition? That is modulus of beta naught minus beta 1 is equal to 2 pi by period of the grating. So if we have more than one wave, the difference between the propagation of the wave should be equal to 2 pi by period of the grating. This is called the phase matching condition. If it is satisfied, means energy coupling will be happening. So in Bragg wavelength, the energy of the forward propagating mode can be coupled to the backward propagating mode if the above condition is satisfied. So now let us consider another wave that is propagating with the propagation constant beta 1, that is from left to right. So the energy is propagating, I say, there can be some amount of scattered light. So the energy of the scattered light is coupled to the forward propagating light if the Bragg phase matching condition is satisfied. That is modulus of beta naught minus of beta naught is equal to 2 beta naught, that is equal to 2 pi by period of the grating. So minus beta naught represents the wave that is traveling in the opposite direction. Beta naught is equal to 2 pi n effective by lambda naught. N effective is the refractive index of the fiber. As we have core and cladding materials of different refractive index, effective refractive index of the fiber is denoted as N effective. Lambda naught is the wavelength of the incident wave. Lambda naught is equal to 2n effective into period of the grating. Then lambda naught is also called as the Bragg wavelength. Reflection efficiency. How much amount of light is reflected? This reflection efficiency decreases as the wavelength of the incident wave is detuned, that is away from the Bragg wavelength. If the incoming beam is having a wavelength which is away from the Bragg wavelength, means the reflection efficiency will be reduced. Suppose if you are transmitting several wavelengths into the fiber Bragg rating, means then the signal at the Bragg wavelength is alone reflected while other wavelengths are transmitted. That is, a wave that is satisfying the Bragg wavelength condition alone is reflected while the other things are transmitted. So this operation Bragg rating shows a periodic variation refractive index. The incident wave is reflected from each period of the grating. These reflections add in phase when the path length, that is, for each and every wave there will be a path length. If the path length given in terms of lambda naught is equal to half of the incident wavelength lambda naught. So if the reflected wave is having a path length which is equal to half the value of the incident wavelength lambda naught, means they add in phase. This is equivalent to, in terms of n effective, it is written that is equal to lambda naught by 2, which is the Bragg condition. So see these two diagrams. This is the spectrum of the uniform index profile. This is the spectrum for apodized index profile. Here this is the main lobe. These are the side lobes. In apodized profile, there is a main lobe and very small, only one side lobes are present. That too shape is very small. So from this diagram we understand that the undesirable, that is here this energy is lost, this is undesirable lobes. So this is eliminated in the apodized grating. So this is a better one. So in apodized grating, the refractive index change is very small towards the edges of the grating. The bandwidth is measured with the help of this main lobe. This is related to the inversely to the length of the grating. What is lambda? It is a measure of bandwidth of the grating and the wavelength separation between the peak wavelength and the first reflection minimum. So, what are the uses of this fiber gratings? Means they are used as filters, airdrop multiplexers and compensators. Why we go for this Bragg grating means it has a lot of advantages, like the loss is less, it can be easily coupled with other fibers, it is insensitive to polarization, it is low temperature coefficient, the packaging of the fiber gratings is very easy and simple, it is low cost. Then how is gratings are written in fibers? By using the photosensitivity property of the optical fibers, it is written. So, exposing the fiber to the UV light, that is ultraviolet light, causes the changes in the refractive index. At the predetermined position of the fibers, UV rays are exposed so that in that particular location the refractive index is changed, so it acts as a grating. What material is used? Silica fiber doped with germanium is used because they are highly photosensitive. That is, with respect to light, they have very good sensitivity. A grating is written, the grating written on such a fiber by exposing its core to interfering UV beams. In the core of the fiber is exposed to the two interfering ultraviolet rays so that the grating can be formed. So, with the help of the radiation intensity, the refractive index is changed. When the intensity is high, the refractive index is more. When it is low, the refractive index remains the same. The change in refractive index needed to obtain the gratings is very small. A very small change in refractive index is CNF in order to obtain a grating. What are the other techniques available to produce gratings are phase mask. This is also used to produce gratings. What is a phase mask? It is a diffractive optical element. When this element is illuminated by a light beam, it splits the beam into different diffractive orders, which then interfere with one another to write the grating into the fiber. So, incident of the light beam is taking place, then splitting of the beam into different diffractive orders, then they are made to interfere to write the grating. Then what is the fiber gratings can also be classified based on the period of the grating. Short period gratings and long period gratings. So a comparison is made with the wavelength. If the period of the grating is very nearer to the wavelength or comparable to the wavelength, that is, it is around 0.5 micrometer, means I say it is a short period grating or Bragg grating. Suppose if the period is very large than a wavelength, that is what its value means, to hundreds of micrometers to millimeters means we call it as a long period gratings. Thank you.